Hello everyone, hope you're having a fabulous day. We're going to continue on with polygons, and this time we're going to focus on the exterior angles that you can find with them. So to begin, let's remember that when you look at the exterior angle of a polygon, it's always going to be supplementary with the adjacent interior angle. So the interior angle and the exterior angle are supplementary. This is telling you that the interior angle and the exterior angle always create a linear pair. For example, when you look at this image of a triangle, my interior angle 79 and my exterior angle will have to be a linear pair. So figure out what angle measure you're going to need. That would have to be 101 degrees. Also then my interior angle 40 and my exterior angle also need to be a linear pair. I need that sum of 180 degrees, so find out what that missing measurement is. And when you look at that last angle on the triangle, I have an interior angle given as 61. Find that exterior angle so that we can determine this, 119. Using these exterior angles that we just worked so hard to calculate, what's the sum of those exterior angles? Go ahead and check it out. Add those together in your calculator. And when you do that, you add them together and realize that you get 360 degrees. I'd like you also to take a moment, try that out with the quadrilateral, the pentagon, and the hexagon that are on this page. Pause the video, work out those numbers. Once you've completed all three of those, then press play on the video again and we'll come back and see what other conclusions we can make. All right, so now that we have found all of these exterior angles on each individual figure, I hope you also have gone through and calculated the sum for them. So when I look for the sum on the exterior angles of the quadrilateral, I come up with 360 degrees. When I examined the pentagon and got these great angles, I can add them up and find the sum. That calculation is 360 degrees. And on the hexagon, we add up those 6 exterior angles that you got, the total is 360 degrees. What kind of a conclusion can you draw from all of this, right? I'd say that the sum of the exterior angles in any polygon is 360 degrees, right? We just showed how that works for 4 of them. This also holds true. It actually is called the exterior angle theorem of a polygon. For any polygon, when you extend those exterior angles in one direction, right? So if you notice, all of these would go the same direction, kind of like if you're picturing a water wheel or a windmill. All of the exterior angles extend in the same direction. But when you do that, their sum will always be 360 degrees. Let's go ahead and use this rule and try to solve some problems. So example 1 wants us to solve for x and y in the regular polygon. So being that we know this is a regular polygon, finding my exterior angle is going to take that 360 degree total and divide it by how many regular angles do I have in the regular polygon? Well, it's a hexagon, 1, 2, 3, 4, 5, 6. So 360 divided by 6 gives me 60 degrees. There you go. That's my measurement for x. I'm going to take my 360 total, divide it by the number of angles that are sharing this. Now to find y, we're going to have to go back and think a little bit about those interior angles that we did last time. So when we're looking for y, I'm thinking about n minus 2 to find me the number of triangles times 180. So that'll give me my interior sum. Then I have to divide by the number of angles that I have. In this case, we're talking about a hexagon. So 6 minus 2 times 180 puts us at 720. Divide that by the 6 angles that we are sharing them all amongst. This tells me that y is 120 degrees. Now again, since this is a regular polygon, every interior angle has to be congruent. So you could very well use that fact and know that this is angle y. Check your work. Does angle y and angle x create a linear pair? Would 120 and 60 give me that 180 degrees? Absolutely. We're on the right track. So when we take a look at example 2 then, we got lots of variables to find. We're going to look for w, x, y, and z in this polygon. So I begin looking for where I have my repeated variables, right? W only shows up once, but I do have a lot of z's. All of my z's are exterior angles. So we're going to use that for our sum. The z minus 13 and the z and the z plus 10. All of those together have to give me 360 degrees for the exterior angles. So I'm going to get 3z minus 3 equals 360. Continue solving there. Add the 3 to both sides. So that's 3z equals to 363. Divide both sides then by that 3 coefficient. Z is 121. So that's one angle that we can fill in. Use this, let's plug into some other ones. So z minus 13, 121 minus 13 puts us at a measurement of 108. And the z plus 10, so 121 plus 10 would give us 131 for that angle. Using these, now let's find the linear pairs for each interior angle. My x plus my z has to have a 180 total, so that's going to require an extra 59 degrees at angle x. Then my 108 and my w have to be 180 degrees to get that supplementary, which means w is 72 degrees. And lastly, the y that I want, well, maybe I want to find that by doing the interior angle sum, or maybe I just want to go ahead and use the linear pair for the y and the 131. Either method will certainly work for us. Y is 49 degrees for that. So when you flip over to the back then, example 3 wants to know about the measure of each interior angle, each exterior angle there in a regular hexagon. So regular hexagon has 6 sides to it, and I want to know each, just one individual exterior angle. So we're going to take the 360 total for my exteriors, divide it by the 6 angles that are all sharing them. That makes 60 degrees for us at one exterior angle. Example 4 is going to look for the measure of each exterior angle in a 24gon. So we're going to work with that 24gon. Again, my 360 total gets divided by the number of angles. Well, that happens to be equivalent to the number of sides. So 360 divided by 24 would give us 15 degrees in each exterior angle. Moving on down a little bit then, example 5. I'm told here that the exterior angle in a regular polygon is 12 degrees. One exterior angle is 12 degrees. So we're finding out how many sides does the polygon have. So that rule that we just used in the last 2 examples took 360 divided by the number of angles to find out how many degrees it was. We're going to turn that around this time, and we're going to do 360 total divided by the number of degrees that I have in the angle to figure out how many angles are there. So 360 divided by 12 puts me at 30 angles, and lucky for us, the number of angles is equal to the number of sides. So example 6 then says that if your exterior angle is going to measure 40 degrees, what's the name of the polygon? So my exterior angle is 40 degrees, find the name. I'm going to use that same idea that I just did in example 5. If I take a 360 total for the exterior and divide it by the number of degrees that it has, that will tell me how many angles it's sharing amongst. So that means that I've got 9 angles. Well, nice enough, 9 angles translates to 9 sides. So what is the name of the polygon for someone with 9 sides? That is a nonagon. Continue on down the page then to your example 7, and we're going to assume that we've got all regular figures shown in this diagram. So what I actually want to do is split this apart a little bit. To find that x, I'm going to divide it into 2 exterior angles. So I'm going to look on the left side here to find this exterior angle. I'll call it y. So find out how many sides the polygon has. Let's see, 1, 2, 3, 4, 5, 6, 7. Don't be afraid to mark them off or count it out. So 360 degrees total divided by 7 exterior angles is going to leave me with, well, that's a decimal about 51.4 degrees. Then I've got to look at the other portion of this figure. I'll go ahead and call this variable w. Got to figure out how many sides I've got. 1, 2, 3, 4, 5, 6, 7, 8 sides in that polygon. So 360 divided by these 8 exterior angles is going to be leaving me with 45 degrees for each of them. So to find my angle x, I'm going to need to take my y value of 51.4 and add on my w value of 45. So x is approximately 96.4 degrees. So when you go on to example 8, again, all figures are regular in these polygons, and we're going to solve for x. We're going to use a little bit of that tessellation idea that we had talked about previously. At any single point, I know that all of the figures have to come together as a complete circle, 360 degrees. So we need to break this apart and find all of these little pieces. In order to get x, I've got to know w, y, and z. So to do that, let's go ahead with W. This is the interior angle on a pentagon. So I'm going to do 5 sides minus 2 times 180 and divide it by the 5 sides again because it is regular. So they are all equal and even. That would tell me that this W measurement is then going to be 108 degrees. Then I'll go ahead and find that y section in a triangle. So for y, I'm thinking about 180 degrees in a triangle divided by all 3 angles because they'll share it equally. That's 60 degrees. And lastly, I would need to know about that z section. This is a pentagon again. So right, the 5 sides minus 2 needs to multiply by 180, divide by 5, and look at that, we get 108 again, just like we did for W, because they were both regular pentagons. So back to that idea of x. What am I doing? Well, remember, your x plus your y plus your z plus your w all together had to be 360 degrees. So plug in these values and solve the equation so we can figure out what we have left. And x is 84 degrees for us. Now example 9 is giving me a regular polygon, and my exterior angle here measures 18 degrees. So take that. This is going to be very similar to the examples 4 and 5 that we went through. I know 360 degrees is my total exterior measurement. If I have 18 degrees in that one, we can go ahead and divide it, right? Just like we did in example 5, divide by the number of degrees. That tells me the number of angles that I have. Same thing here. I'll divide by the amount of degrees. That will tell me how many angles I have, and we know that the number of angles is the same as the number of sides. So this polygon has 20 sides. It's a 20gon. All right, example 10 now. We got some figures coming together here, and we're going to use them all as regular polygons for us. So to begin by finding that x, I'm going to split this apart again. Finding the x is going to be along the same lines as what we did in example 7. Look for the 2 exterior angles that we have here. So figure out how many sides you have to the figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there. So when I do 360 divided by 10, that would tell me that I have 36 degrees in that angle y section. Then I've got to know about this other portion. If I call that z, It's 1, 2, 3, 4, 5, 6, 7 sides on that figure. So 360 divided by 7 would put us at 51.4 degrees. So to find our x, we need to add these together. This is 87.4 degrees for the measurement of x. Then when we go looking for y, we're going to use that idea about all of the points at one central location have to have angles that total 360 degrees. Well, lucky for us, we can see that the quadrilateral is regular, and so that's a square, right? To be regular has equal sides and equal angles, so those equal angles are all going to be 90 degrees for us. We can see that we have a triangle. A regular triangle is an equilateral triangle, equiangular triangle, so you've got 60 degrees there. Now we just need to find that interior angle then for the septagon. So in order to do that, I'm going to think about the number of sides minus 2 times 180 divided by the number of interior angles that we are sharing this with. A little bit of calculations there would put us at 128.6. So to find y, we've got to make sure that all of these items have that 360 total that we need. So my 90 from the regular quadrilateral and my 128.6 from the regular septagon, heptagon, whichever you prefer to call it, plus the 60 from my regular triangle, plus the y that I'm looking for, need to have that 360 total for us. So we will keep that on going, and with a little bit of calculations, then my y value would be 81.4 degrees. So example 11 here to finish out the bottom of your notes page gives me one interior angle measure in a regular polygon. So there are two different ways that we can figure out how many sides the polygon has. So that's why we've got this split up into a method 1 and a method 2 section. I'll show you both of them. You can choose the one that you prefer. So in method 1, I'm going to use the fact that I know an interior angle and the exterior angle are a linear pair, so they have a supplementary sum of 180 degrees. In this case, I was just told that the one interior angle is 156. So let's go ahead and figure out what the exterior angle that matches it is, solve that equation, and it turns out that the exterior angle we're dealing with is 24 degrees. We did problems like this up above where you were given the exterior angle measure in degrees. Like, look at that, example 5 and example 6, given the exterior angle in degrees. What did we do there? We took our 360 total and divided by the number of degrees in that one angle to find out how many angles we had. So that makes 15 angles, which also then implies that we're talking about 15 sides. That's one completely mathematically acceptable way to solve this question. How about another version then? When I look over and try this out in method 2, I'm given an interior angle measure. So when we think interior angles, we're thinking about that interior sum n minus 2 times 180. And it was in this case just the one angle measure, so clearly my sum had to be divided by the number of angles that it was all shared amongst. This math gives me 156. So we're going to be solving an equation here to make this work. First of all, you're going to tell me that you don't like the fraction, so let's go ahead and clear the fraction. Multiply by that denominator as an n over 1, and what you multiply to one side, you got to multiply to the other side. So n numerator and n denominator cancel to a factor of 1. So I've now got n minus 2 times 180 that's equal to 156n. I've got to remember to distribute. This 180 has to multiply to both elements within my parentheses. So I'm thinking about 180n minus 360 equal to that 156n. I want to move all my variables to the same side, so I'm going to subtract 180n from both of those. So a negative 360 is equal to a negative 24n. Divide both sides by this coefficient of a negative 24 now. So positive 15 is equal to n, where that tells me, right, n is the number of sides, so we're talking about 15 sides. Either way, you're going to get the same answer. It depends on what your comfort level is or how much of an equation or arithmetic you want to do for it. I hope that these polygons and all of their angle measurements are really starting to come together for you. Have an awesome day.